So, the name of our project is Information Extraction and Inferencing System. Starting from the abstract, the rising number of substance abuse cases is a serious situation that demands significant attention from authorities. A system that can provide valuable information regarding this epidemic can be helpful in handling these issues efficiently. The developed system extracts the news reported on substance abuse related crimes from online resources like newspapers, articles, etc. Then process the extracted data using natural language processing techniques to generate a set of information that can be helpful in generating valuable inferences. Moving on to the introduction. The abuse of drug continues to be a major health problem internationally. These are some statistics from some reliable sources like the United Nations Office on Drug and Crime reports that approximately 5% of the world's population used an illicit drug in 2010, and 27 million people, or 0.6% of the world's adult population, can be classified as problem drug users. And it is estimated that alcohol abuse results in 2.5 million deaths per year, and that heroin, cocaine and other drugs are responsible for 0.1 to 0.2 million deaths per year. In addition to causing death, substance abuse is also responsible for significant morbidity, and the treatment of the drug addiction creates a tremendous burden on society. For generating valuable information regarding this problem, a system is developed to extract information from online news articles and give inferences about the cases. The problem statement. Significant rise in the reported drug abuse case is a serious public health threat. If there was a system that generates valuable inferences from the news concerned with the issue, it would have helped a lot in handling these problems. The system that has been developed provide effectively organized information by processing the news reports concerning the drug abuse cases. The news reports are extracted from internet sources through web crawling and processed using NLP techniques. So moving on to the system architecture. Starting from the system storage or disk storage, this is the computer that we use, or maybe the laptop that we are running the program from. So what it does is, it actually has training data which will be manually annotated and which will be explained in the next sections. So we have training data which we pass to the processing module of a complete section, like a Python program with 3 parts: NER module, processing module and rule-based extractor. So the training data is passed to processing module, from where it is passed to an NER section, and an NER training module will train the NER model and save the updated model back to the system storage. So again, for the testing purpose, the trained NER model from the disk storage is loaded into the processing module again, and named entity recognizer section or NER section is so the training model is loaded into the processing module, and named entity recognition or NER is performed from the NER module, from which we can extract the data, the NER named entities, out of the reports that we collected from the web crawler. There is a web crawler module right above the system storage disk. So we get articles from online resources by web crawling, which will be there in system storage, and using this pre-trained model we can extract the named entities like names, geolocations, or time, date, or maybe the name and quantity of drug in case of our project, and extract those kind of entities for later use or processing. After that, these processed information are feeded into a rule-based extractor, where it searches for semantic connection between the bits and pieces of the entities that it extracted, and then establish some connection and gives out the output as a key information, which is a meaningful information that can mean something. That's basically the system architecture as a whole. And in the next section there is 3 steps, that is creating dataset, training spaces, statistical NER model, testing the model, and tool based extraction. So that's how that's the 3 steps of our information extraction and inferencing. We are using Spaces statistical NER model or named entity recognition model for our NER, and the model is actually working like this flowchart, where the model is actually trained with the text and label for a period of time, like with following an algorithm which is specific to Spaces. And the model, when it is ready with all the training, it will again pass the text, and the model has to predict the label, and then there is a gradient, which is actually the difference between the actual label and the predicted label. So the model will iterate through a number of training sessions to minimize the actual gradient. So that part is called losses. So we have to minimize the losses to get the updated model, and it goes on and on. So moving on to the first step, it was creating dataset. So statistical NER actually require a large amount of manually annotated training data. So there are existing models for most popular languages like English, German, and most European languages. But for Malayalam, we have to create it from the scratch. So data were extracted from online Malayalam newspapers like Manorama, etc. And entity tagging was done using Docano, an open source text annotation tool. And the dataset was got in a JSON format, and the dataset is trained using Spaces. The training part includes the steps done by in connection with the Spaces training algorithm, which is actually a general training algorithm for all Spaces blank model or maybe existing model. So we selected a blank model for Malayalam and trained it using the following, trained it according to the Spaces training algorithm. Moving on to testing. Testing part was to find the accuracy of the model. It is important to test it. So testing was using the non-trained articles to detect whether there was correct predictions, whether the model was able to predict the named entities correctly. For that we crawled the data from online articles with a web crawler that we developed for ourselves, and then got some articles from different online resources, and we used those articles to test the accuracy. Moving on to implementation, this section actually contains the packages and libraries that we used for pulling off, that we use for our project. So the packages include Spaces NER model. So being free and open source library, Spaces has made advanced NLP much simpler. So it is a very good model when it comes to activities related to natural language processing. And then Spaces utility functions, which are mainly used in the training algorithm, util mini batch for creating batches to iterate over, and sizes determined by the util component, compounding yield, util compounding, which yields an infinite series of compounding values. Each time the generator is called, a value is produced by multiplying the previous value by the compounding rate, so we will get varied sizes. And the dataset is generated with Tokeno, and Scrap is used for developing web crawler. So the system was able to generate desirable results to an extent that is satisfying but yet improvable. However, few of the errors arising from the final results may be due to the extensive training that the model required, or some irregularities in recognizing the named entities, both of which require more time to address. But the provided results are promising with a decent accuracy. A test that was conducted with 50 samples yielded with 45% of accuracy, which is a decent number for such an elementary system. So this table actually shows the detailed testing statistics, which actually decompartmentalize each and every entities and show their accuracy. For the location it was 0.84, and the worst one was with date and person with 0.6. So it was a mix of different accuracies for different entities, and combining all the things we got a 45% of accuracy for the entire article. So coming to the conclusion, an automated system for generating valuable information out of online news articles can reduce the colossal amount of effort that must be put in to do the same by other means. The data provided by the system can aid in a variety of domains. Also, information provided is very significant and relevant, as it is regarded an issue of ongoing serious social threat. However, in a broad sense, the services provided by the current version of the system is limited. It can be modified to provide a full-fledged inference which increases its clarity, or it can be enhanced in a way that it responds to the user queries. Also, a UI or user interface can be given to make it more user-friendly. Thank you.